So welcome to all dear students. Here we are going to learn the CHG-290 course. Here the last lecture we learn about what the 18 electron rule and related problems. I hope you understand how to calculate the 18 electron and whether that molecules, that organometallic compounds are stable or unstable. Here we learn the total, how to calculate the number of electrons from the different ligands, not only the carbonyl but different ligand also, which is bonded to the central metal, and each ligand has the capacity to donate the different type of the electrons. Okay, then we will start today the next topic of this chapter, that is the reactions, unique reaction in organometallic chemistry. Okay, here you all learn that reaction, but here we are going to learn in details. You use that, not learn, here you use all this reaction in a different cycle, that is the Wacker process, Monsanto process. You already learned all that process, and in that process you used all these typical reaction. Okay, so today we are going to learn in details what are these reaction, their mechanisms, their basic conditions. Okay, their basic reactions are: first, that is oxidative addition; second, that is reductive elimination reaction; third, that is called as a migratory insertion reaction; and the fourth one, that is called as a beta hydrogen elimination reactions. Okay, so start with the first, that is what the oxidative addition reaction. What is the oxidative addition? You know very well. Here this word, that is oxidative addition, itself define how oxidative means what, where what oxidation reaction which takes place. Okay, what happened here? The oxidation takes place. And addition means what? There is an addition of the ligands which can be takes place in the reactions, that is called as oxidative addition. When the addition of ligand is accompanied by the oxidation, what here, oxidation of what? The central metal. Okay, whenever the central metal increase in their oxidation state, that is called as what? Oxidation. That means in the oxidative addition reaction, whenever central metal have the oxidation, by increasing their oxidation number, that is called as a oxidative addition reaction. This is a typical example, or here this is the how let me see the oxidative addition. That is here, this is our organometallic compound LNM. Ln means what? Ln is the ligand, and M means what? M is the metal. Okay, whenever this organometallic compound which is reacted with the another reagent, okay, then whenever this reagent which is attached, bonded to the organometallic compound, okay, by increasing their oxidation number, that is called as a oxidative addition reactions. It had some condition. First one, here how we identify whether this reaction is oxidative addition or the other reactions. It had some condition. The first condition is what? The oxidation state of metal is always increased by what? Increased by the 2 units. This is very important. The conditions for the oxidative addition is the oxidation state of the metal is increased by unit 2. Let me see by the example. This is the our example. that is RHClPPH3. okay, chloro triphosphorodium. okay, this on oxidative addition with the H2 molecule. This H2 molecule is the reagent. Then this H2 is attached to this molecule by 2, and here in the first case the oxidation state of this RH is +1. okay, oxidation state is what? +1. Then by the addition of H2 into that RH group, then what happened? Their oxidation state is increased to +3. That means it is increased by which unit? 2 units. okay, that means what is the condition for that? The oxidation state of the metal increased by unit 2. Second is what? The coordination number is also increased by the unit 2. Let me see. What is the coordination number? Coordination number means there is a number of ligand is directly bonded to the central metal. That is called as the coordination number. Here in first case, what happened? This RH is bonded to 1, 2, 3, 4. Okay, 4 ligands. That's why the coordination number is 4. okay, and whenever the product will form, what is the coordination number of this molecule? That is how many ligands which is attached to this molecule? This is 6. That's why this molecule has a coordination number 6. That means this also coordination number is increased by what? The 2 units. okay, third is what? The 2 new ionic ligand are added to the metal. Third condition is what? 2 ionic ligand is added to the metal. Here there are the 2 hydrogen is there. 2 hydrogen is separately attached to this rhodium. Not H2 is attached to the rhodium. There is a 2 hydrogens are attached to the rhodium. That's why 2 anionic units are attached to the central metal. okay, that's why this is called as oxidative addition reaction. okay, this is very important. Then let me see requirement for the oxidative addition. This is the condition to identify the oxidative addition reaction. Let me see the requirement. First is what? The availability of a non-bonded electron density on the metal. Then that means what? Metal must be have the empty orbital. Next, to vacant coordination site on the reacting complex. That is, the complex must be coordinatively unsaturated. This is very important. That means what? Here, if the reactant already have the 6 member, coordination number is 6, that time what happens? There is no any space to add new ligands. That's why here the oxidation reaction which cannot be happens. Means what? This compound or organometallic compound must have what? Coordinatively unsaturated. okay, that means the coordination number must be low. Then only the new ligands which can be attached to the that molecule. okay, because they require empty space for the addition of the ligand to that of the metal. Next is what? The metal with a stable oxidation state separated by 2 units. The higher oxidation state must be energetically accessible and stable. okay, that means the metal must be have the low oxidation state, and that's why here by the addition of the ligand their oxidation state is going to increase. okay, next we learn the oxidative addition involving, this is also important, also asked in a net set examination, CH bonding activation or what? And the cyclo or orthometallation, or it is also called as what? Orthometallation process. What is the orthometallation process? Let me see. Here this is our reactant which have iridium, having a +1 oxidation state. okay, and here this is a 3ppH3. okay, triphenyl phosphorus unit. okay, for our convenience what happened? We convert one phenyl group like this manner. okay, this is the ppH3. It get converted to ppH2 and one phenyl group we draw their structure. okay, and here this one phenyl all these carbon which is attached to what? The hydrogens, like this one. Then what happened here? The from the one phenyl ring, this hydrogen of the one carbon and the CH bond is going to break. Okay. Then what happened here? By breaking, by breaking this bond, this hydrogen which is attached to the iridium and this carbon also attached to the iridium. This type of interaction, that means here we doesn't get any ligand from the outsource. Okay, we break the bond between the ligand which is already attached to the central metal. By breaking this CH bond, the hydrogen and carbon which is separately attached to this iridium, okay, by increasing their oxidation state by unit 2. That means here in this case, this molecule, this iridium has +1 oxidation state, and in this product this iridium has +3 oxidation state. Okay, this type of interaction is called as a agostic interaction. Okay, and this activation or this breaking of CH bond is called as the CH activation. That means that this type of reaction help to activate unreactive hydrocarbons, okay, such as methane, known as CH activation. That is called as what? CH activation. And this type of interaction is known as what? Agostic interaction. Okay, what you see here, this is the one phenyl ring which break their CH bond, and this carbon and hydrogen separately bonded to that of the what? Iridium, that of the central metal atom, by increasing their oxidation state. That's why this is called as oxidative addition reaction, and this type of interaction is known as agostic interaction. This is about what? Oxidative addition reaction. Let me see next, that is opposite, totally opposite to that of the reaction, is known as what? Reductive elimination reaction. That means what? Which process takes place over here? Reduction. Very good. Or here what happened? This is reduction reaction which can be takes place, and second thing what is what? Elimination which can be takes place in that reaction. This is exact reverse of the oxidative addition. Okay, let me see. This is our reactant which has oxidation state +4. Okay, and by the elimination, reductive elimination, what happened? This 2CH3 group which is going to break their bond, and there is a formation of the molecule, that is ethane. Okay, by removing 2 units from this platinum, here their oxidation state is going to changes, decreases. That is, platinum get converted to +2 oxidation state. That's why this is what happened here. Reduction is takes place, decrease in oxidation state, that is reduction, and there is a elimination of 2 methyl group is takes place, that is called as a elimination. That's why this process is known as a reductive elimination process. It also has some condition which is totally opposite to the oxidative addition reaction. What are these conditions? First, that is oxidation state of metal decrease by 2 units. Okay, here this platinum which has +4 oxidation state, and by the formation of the product, their oxidation state is going to decrease to the +2. That means this is decreased by what? 2 units. Here second condition, coordination number, it decreased by 2 units. Here in the first case their coordination number is 6. Okay, and after formation of product their coordination number is changes to 4. That means this is also decreased by what? 2 units. Next, here the 2 cis-oriented anionic ligand form a stable sigma bond. Okay, and leave the metal. Always what happen here, the cis product is going to break and to form a sigma bond. You can see here this leaving group. Okay, there is a 2 methyl group or this which are in a cis position which are going to break, and there is a formation of the sigma bond, and after the formation of the molecule they leave the metal. Okay, and and there is formation of the product. Okay, these are the condition for reductive elimination reaction. Let me see the factor which facilitate the reductive elimination reaction. First factor, that is the high formal positive charge on the metal ion. That means what? The metal ion must be having the high formal charge or high oxidation state, high oxidation number or the oxidation state. Second is in presence of bulky group on the metal ion. Metal ion always have the bulky group. Why? Because this bulky group which always repel to the living group to live. Okay, that's why here the presence of the bulky group is very important. And here this is electronically stable organic product which is formed. This is always what? The electronically stable. Okay, next is what? Cis orientation of the groups taking part in reductive elimination is very important. For the elimination, the two living group must be in a cis position. Okay, let me see the example of that. Here these are some example. If here if these are here the two hydrogens which is attached to over here, then what happens? These two hydrogen is, these are homolytic, that's why this can be easily removed. That's why this is very fast reaction and reversible. Next, here this is a hetero atom is there, and this hetero atom, for removing this hetero atom, it is somewhat quite difficult, and that's why here this is very easy to remove this bond, and here two negative poles which is attract together, and there is a formation of the molecule, and that's why this is very fast process. Okay, reverse is fairly rare. Okay, that's why here the reversible reaction which is not possible. Okay, sometime it will be possible. And here this is 2 RR group, that means same charge which is there, and that's why here for binding these compound is quite difficult, and that's why this process is very slow and reverse is very rare. Okay, then next is, let me see the examples of that. Here this is our compound. What I said to you, this is always what? This living group must be in a cis position. Okay, must be in a cis position, then only we get the product like this. Okay, but here this question is asked in the net examination, what will be the product? This compound given in the net examination, they said what is the product. Here what is the condition for the reductive elimination reaction? This living group must be in what? Cis position, then only they can live, and there is a formation of the product. But whenever here this living group which are in a transposition, here you can see in the transposition, they are not live, and that's why no reaction will be happen over here. Okay, next we will learn, that is here this is the some what the symbolic reaction is selenium AB. Yeah, what is elimination? AB get removed to form a bond. Okay, that is called as elimination. If there are the dimetallic organometallic compound is there, that time 2AB, this here AB get removed, and metal form, there is a formation of double bond, and this molecule get removed. If here the two different compound is there, and that time here this two metal which is binds together, and by removing the AA group. Okay, okay, this is about what? Reductive elimination reaction. Let me see, that is the examples of, sorry, here this is the some importance of what? The reductive elimination and oxidative addition reaction. Okay, here these are the reaction which is useful in some cycle, that is what? Here this is the Wilkinson catalyst which is used in what? The hydrogenation of the alkene. Okay, here what happened? This is RH which is on H2 oxidative addition reaction, this is attached to the cis position. You can see this is attached to the cis position. This is called as what? Oxidative addition. But this is reverse reaction. That means what happened here? On the reverse reaction, this REH get converted to +1 oxidation state and H2 get removed. That time this is called as what? Reductive elimination. Reductive elimination reaction. Likewise here, this is the methanol get converted to the acetic acid, that is called as a Kataiwa process. Here two hetero atoms which is bonded to these compound in the cis position. That time what happened? This is a oxidative addition reaction where the CH3 and iodine, methyl iodide, which is bonded separately to that of the central metal, that is iridium. Then plus here in first case it has a +1 oxidation state, and the second case iridium get converted to the +3 oxidation state. Okay, then here this is called as oxidative addition reaction. Whenever we reverse that reaction, that is called as what? Reductive elimination reaction. Okay, this is about what? The oxidative addition and reductive elimination reaction. Today we learn what? The oxidative addition and reductive elimination reactions in detail. Okay, thank you very much for your attention. Okay, next time we will learn the next type of the reaction which is mostly used in the organometallic compound. Okay, so thank you very much for watching this lecture. Okay, study it and don't forget to comment as writing your roll number. Thank you.